Yeah, sorry.
Welcome to Developers Meeting on Sunday, the 30th of April, 2023. We are here having had a long discussion about internal things, and now we go over into what happened in development the last couple of days. And I think I'm calling it out now is that David got something of very much interest. David, can you demo
Okay.
something or tell us what results you could produce this week?
Yeah, sure. So I was trying to pull as much information as possible from that large data set of Richard's. So we had a traveling hard drive that goes around to various people, but on that hard drive there's thousands of videos. I think I've probably recorded over about 6 months. Richard, is that right? Maybe.
Longer, 1.5 years.
Okay, yeah. I managed to pull off 2 folders before I sent it on to Nicola, which is 190 gigabytes. But anyway, I thought it'd be quite nice to just kind of pull off as much information about what's on those videos. So I wrote a script that pulls various data based on the time and the location. So I can briefly show you. It's not particularly exciting. But I'll show you anyway. 1 sec. Yeah, so I wrote this script. It's basically just reading a frame from each of the videos. From the frame, it detects the time, detect the resolution, the duration, and then it pulls information from different APIs. So this is building on the work that Jannik's been doing with the weather APIs, and last week with the METAR API. So it's recording a bunch of different data for each video, and then it writes it into a spreadsheet. So you can see here we've got.
Can you make it larger? Is that possible?
Yeah, sure. Just tell me if you can't see anything. Is that any better?
A little fuzzy.
A bit more?
A little bit more, yeah. Yeah, that's better. Yeah.
Okay. Yeah, so I mean, this is just a sample of what it's doing. It's eventually it'll iterate through every single video in that data set and record all of this information for each of the videos. I guess the general idea is just having some sort of summary spreadsheet that we can go into and learn about what data we've learn a little bit more about what the data that we've got. So we've got the video file name over here. We've got the time of the first frame, and that's just read from the clock information that's just written over the frame. The duration, the resolution, and then pulling some stuff from that visual crossing data store, so that weather API, so sunrise, sunset. Along with all this, I've been testing out some of the Sky 360 algorithms. So we've got an algorithm in the repository that detects whether we're in the day or the night. So basically, I wrote that in here as well, so we could look at the actual timings pulled from the weather API and see whether it's doing a good job of detecting whether it's day or night.
Why?
So you can see on this first.
May I ask you?
Yeah, sure. Go ahead.
Why is in line 2 and 3 a discrepancy in day-night when the sunset Oh, the timing is somewhere else. The timing is there. Sorry, I didn't see that. Okay,
Yeah.
yeah, sorry. You're right. Okay.
So you can see that falls out of. So that is correctly classified as night. I think all of these are correct. So it gives us some confidence in that algorithm. And of course, when we get the full data set analyzed, we could look at how accurate it is. But just going off these 20 odd videos, it seems to do a reasonable job. And the weather API, it gives us conditions. It gives us cloud cover from that weather API as a percentage. And then I'm writing in here the Sky 360 algorithm cloud cover estimates. There is a bit of difference between these, and I kind of expected that. I mean, the weather API is taking a aggregate kind of average, I suppose a weighted average across different weather stations that are in the area, whereas this is Sky 360 cloud cover estimator is just making an estimate of what's in the frame at that very localized position. So yeah, although there is some kind of agreement, and I've been looking through these videos, and I would agree with the Sky 360 cloud cover estimator. It does a pretty good job actually of getting it right. And then building on Jannik's work from last week, and thanks to Jannik for pointing me in the direction of this API, but you can pull METAR data and it gives you cloud height. So you can see for a few of these videos, it's been able to pull out the cloud conditions, but also the cloud height, which is quite nice. Any that it doesn't write at the moment is clear conditions.
Okay.
Wind data and two different APIs. We've got the METAR wind readings and we've got the weather API readings. So you can see there's mostly agreement between those, which is interesting. Moon visibility, the METAR station and the weather station that's local to your station, Richard. Well, maybe pick out one of these just to kind of show it. Maybe that one's quite interesting. So it's saying we've got kind of 3 layers of cloud. I think we've got a few clouds at 3,000 feet, broken clouds at 3.5, and then some towering cumulus at 3.5. So I just go back, copy that string. There we go. So you can see the different layers of cloud in there.
Wow, indeed.
And the Sky 360 cloud estimate is doing pretty good. Yeah, but I guess it's just pulling as much data as we can. The other idea I had is getting the ADS-B data to see what planes were in, like 10 or 15 nautical miles of the station at the time of each of these videos, which might be interesting as well. So we can determine which videos might be interesting for watching to see, to get plane data. That's about it. So yeah, not much else to say.
Cool. So the basic idea is to create an index file for the whole data set, right?
Yeah, that's right. Yeah.
So for the training material data set, so that, for example, Nicola can pick it up and teach an AI, train an AI on it.
Yeah, it's got like one big summary spreadsheet, or it's written as a CSV file, so it could be any kind of form. But yeah, if Nicola or any of the others wanted to use it later on, they could sort the spreadsheet by, I don't know, cloud type, or whether it's got aircraft in there, or could be quite useful.
Would be interesting whether it's possible to train an AI based on that information that you retrieved. You know what I'm saying? That, for example, an AI can see a video and say, looks like this is cloud layer 3,000 feet, for example.
Good point. Yeah. I'll defer to somebody else with AI expertise there, because I'm not that good. But I guess you could train a neural net to recognize different cloud layers. That'd be cool.
And directions and speed, wind speed, and so forth. I think if the parameters are already in an index file, and let's say we call this the ground truth, I think it should be possible to create a neural network that finds these parameters by videos, looking at videos, or seeing the video images.
Great.
Hey, there's another idea that comes from Chris Dixon, and the idea is a sky quality meter. I think his idea is derived from astronomers that check for places and times when it's best to capture images from faraway galaxies. So they have an index that's called the Bortle meter. And it basically gives, I think, some classes, and in each class it says what star has what magnification, a light magnification. But there are also devices that do that. So a device that has a little lens, and you put it up, it has a USB connector to a board, and it gives you parameters of sky quality for astronomic or optical use. I just throw it in this idea because it for me it belongs somewhere to what you did.
It sounds good. And also the light pollution and things like that. Is that the idea?
That's the idea. That's the light pollution thingy. Yeah. And they have a measurement in Bortle, B-O-R-T-L-E, Bortle meter.
Okay.
Maybe you can check. Jannik, did you know about sky quality measured in Bortle meters? Jannik, you're there?
Did you say
yes, I was just about to move to go. I have to go actually, but what was the question? Maybe I can answer that question quickly.
Bad boy. So okay, the question is about light pollution. It's a typical question for astronomers, because when they rig their telescopes, they want to know whether it's a good night to take pictures of, I don't know, any star. So, and they measure with a device, they measure in Bortle, B-O-R-T-L-E. Bortle.
Okay.
And it's a scale, and each scale has particular stars with particular magnifications if they are coming with this Bortle scale, and then going into this class. But never heard a thing. It's about light pollution.
I've not heard that. We measure light in watts per square meter, for example. So I'm used to SI units. So.
Yeah, okay, so it is daylight. What in the night?
We usually we still measure. We are not very interested in nighttime lights actually, but because it doesn't have a great impact on anything that we are interested in, but we would still measure that in watts per square meter. I mean, even if it's
moonlight.
Yeah, I mean, in metrology, you're not so interested in moonlight, so not that I'm aware of, at least. Yeah.
Okay.
But that's how we measure it, basically. Yeah.
And you measure
Okay,
it with an albedo meter, a light meter, or something like this. Sorry.
Yeah, yeah, exactly. So we have sensors to measure that, and it usually heats up a black plate, and then we convert that into a measure of light.
Mm-hmm.
That's usually how the sensor works.
From the material and the increase of temperature, you derive the watts per square meter.
Yeah.
Kind of. Okay.
Yeah. Yeah, but I actually have to move on to the next thing. So
okay.
Have a good one.
Thanks, Jannik. Bye-bye.
See you.
All right. Fabio.
Yeah.
Okay, sorry, David, go ahead.
No, I mean, with those videos now, we've got the time and the location. We could maybe pull out the light pollution measures and write that to the spreadsheet as well. I guess that could be useful at some point.
There's a server that's called light pollution something.
Yeah,
and they have an API. Yeah, sorry.
Is that it? Yeah.
Where you see them. Yeah, exactly that one.
So you're doing okay down in Austria.
Very dark. Great.
Yeah, that's good. It's terrible around here.
Look at Holland. Oh dear.
Yeah.
Or north of Italy. Oh dear.
What is this red?
Is the amount of light pollution.
Oh.
There's a dark sky map too.
We are talking about LED light or any light?
That's a good question. I think it's more about natural light. Is it natural light or is it...
What you mean by natural light?
Good question. What do you mean with natural light? So there's a natural light where the atmosphere is enlightened by anything that a light that goes through the atmosphere, and this can also bend over the atmosphere towards over the terminator.
United States look like light bulbs, you know, like light pollution, because all the cities were lit up.
And
I mean,
from Earn, yeah. Anyway, so the idea is from Chris Dixon whether a Bortle meter or something along that line, or an API that derives less high quality, is of any use to us. Actually, we can probably pull that data. Not sure whether it helps us, because David already implemented code for creating an auto exposure. So we already can adjust to the current light situation. So I'm not sure whether this brings us anything. Any opinion from you?
How this light pollution can affect our views from cameras from stage?
Yeah, it does basically, because it enlightens the atmosphere and it creates more seeing. So it will, especially to the horizon. So if you look up vertically, it will not have that much effect. Although light pollution also increases all the light in the atmosphere, so you have a much brighter night, starry night. Seeing less stars, but having more grayish background instead of black. And that, of course, changes the...
So Richard, just to talk about the auto exposure thing.
Yeah.
It's still just playing with the exposure, and that's not our aim, because the exposure limits the amount of frames per second that we have. So
True.
if we go over 100 milliseconds, then we'll not be able to get any sort of high-speed vehicle, or it will be just 10 FPS. If we go to 200 milliseconds exposure, then we'll only be able to have a 5 5 FPS something. So we still have to play for other values on the camera to have a real best setup for the exposure settings. Okay, it's not just.
I'm sorry, I didn't hear the last sentence. Can you repeat?
We have a lot of different settings to play.
Yep.
So that we need to play to adjust to the best settings, the best configuration.
Yeah.
Right now, David did a great job with the exposure thing, but we still need to adjust for the other values, or else you'll not be able to get anything at night. We'll just be able to increase the exposure, and we'll not be able to get any sort of UAPs at night that in a decent way.
So, did you? First of all, your experience is based on the camera you're using right now. Are you using it with the cooling or without?
No, in fact, it doesn't matter. Okay, I can use it. I'm using it with the coolant, but the fact it doesn't matter because, for instance, if we increase the exposure to 200 milliseconds, we only have 5 frames per second.
Of course.
And in 5 frames per second or less, we have to increase to 250 milliseconds. We're not be able to track anything. It will appear on one frame, then will appear on the other frame, very far away from what we're seeing. That it will not track. We will see it like one frame, and then we'll see it very far away in another frame, and the tracker will not follow this. So it doesn't matter if it's cooled or not cooled, or I'm just talking about the exposure time. The exposure time limits are frames per second that we use.
But by cooling, we can reduce the exposure time.
No, cooling just reduces the noise.
Noise, yeah.
Yes.
It just reduces the noise. Not the exposure time. No, the cooling will only work with the noise. It will reduce the amount of noise we have in the camera. That's it.
Yes, but in that case, if it is cooled at night, we can use compared to not cool. So I'm comparing only cool versus
of course,
not cool.
Cooler is better because it introduces the noise in the picture.
Yes, and therefore you can reduce your exposure time. And
No,
not really. Not really.
Brilliant. Remember, we were just discussing this with Christian just an hour ago.
That's not true. We can reduce the exposure time. We're just reducing the noise.
Yes,
the cooling of the camera just reduces the amount of noise that we have. Of course, if it's a hot day and we don't have the camera is not cooled, then we have a lot of noise, and then we will have it will be just garbage. If we cool the camera, we have a very better picture there. But okay. Anyway, that doesn't matter because we can reduce it maybe a little bit on the exposure time, but that's nothing important.
Mm-hmm.
What's important here is that we have to play with the gain and also the exposure time. That's the two most important things that we have to play in astrophotography.
Mm-hmm.
And if we increase the gain a lot, we have error the same way. We have a lot of error on the picture. And if we reduce the gain and increase the exposure time, then we reduce the error, but we also reduce the frames per second that we have. That's so what I'm talking about. We need to think about something to have optimal values for us to be capturing things at night. I'm just talking about night because daytime it's okay. Daytime it doesn't matter if we are exposing in one millisecond or 10 or 20 milliseconds. It doesn't matter.
Change the FPS,
yeah. Then the cool will work and everything will be fine. I'm just talking about nighttime. At nighttime, we have to think about the best parameters to use, and it's not just about exposure and cooling. That will not work. That we will not be able to track anything. We'll be able to maybe see, but the automatic tracker will not track it.
Yes.
Because it doesn't know that's the same object.
I get your point. So the too small FPS reduces the accuracy of the tracker. So when there are multiple objects in the same area, then to know which object moved where. We had this discussion with Christian just an hour before the developer meeting, and he expressed that by using a cooled version at night, we can reduce the exposure and increase the gain, because the cooling effect reduces the noise so much that we can still keep up the FPS at night as we did it on the daylight. But sorry to say, I'm just a messenger. I'm not an astronomer.
No,
I'm
no,
just
no.
giving.
On that topic, this is true, but it limits the thing is that gain increases noise,
Yes.
and cooling reduces the noise. That's it.
Yes. Yes.
So of course, if we cool the sensor, we can increase the gain a little bit. That's true, of course. But that's not the point. The point is that we have to figure out the parameters that we can, like the maximum exposure that we can use at night, and then we increase the gain. Because that's what I'm trying to talk about.
Yeah.
For instance, that if you want to keep, for instance, 20 FPS at night, then you have to limit the exposure to 50 milliseconds. That's what the things I'm trying to talk about.
Yes, and then we have to adjust the gain accordingly so that
Yes,
whatever outcome is, that contrast is enough or so.
That's my point.
Yeah.
That's just it. It's just not playing just with the exposure thing.
Yeah.
Because the exposure. Okay, go ahead.
I would rather suggest, because I'm not an astronomer, I'm just giving back what Christian just told us an hour before. I think it's better if you talk directly with him. Maybe David and you can directly exchange with Christian how to set up such an auto exposure, or
to
algorithm.
clean up. Yeah.
No, that's fine. That's perfect. We just need to discuss it. I totally agree. And Christian is right. We can increase the gain if we cool the camera. But anyway, if we increase the gain a lot, we lose a lot of dynamic range on the image itself. So it's always about an optimal or not optimal. An optimal parameters to use. So we have to figure out ways to play with exposure and gain and white balance, and maybe being in a way that we try to get the best out of the parameters. If we increase the gain a lot, it will increase the noise a lot. Even if you cool down the camera to -20, it will increase the noise. And because it's just a multiplier on the amount of the gain is just a multiplier of the amount of pixels that are the amount of photons that are hitting the sensor. If we're having one, then we increase the gain. It's just multiplying that, but it also multiplies the noise. So that's what gains does. So even if we cool the camera, that's great. We can increase the gain, cooling the camera. That's perfect. Christian's totally right. But even so, if we increase the gain a lot, we will still have some noise, and we still have some. We will still lose dynamic range on the image. At night, it doesn't matter. I totally agree. It doesn't matter that much, but at night. But we just have to figure out the parameters to use.
Yeah.
I think the most important parameters that we have to think about it is, if we're talking about tracking things, we need to think about it is the amount of frames per second that we want to use from the camera. And so that limits us to like 50 milliseconds or something like this that we have to figure out. And that's it. If we can only increase the exposure to 50 milliseconds, how much we have to increase the gain to have enough light in the sensor? That's it. I'm just talking about it.
Yeah.
But other than that, you're right, and Christian is right. It's totally right. If you cool the camera, we can increase the gain without increasing the noise that much.
And we can even change the. Now we can even tune the cooling of the camera. We can adjust it. So.
Yeah, you can.
There is also a parameter that is variable.
Even we can let's assume that we keep the camera at -10, -15. That doesn't matter, and that will be the optimal value for the camera, for the sensor. And we have to think about they have the best cooling possible, and then we have to think about the gain and the exposure and everything else, so we can have the best auto exposure, the settings for shooting.
Yeah.
When it's down, when it's dark, because when it's down, we have a problem, a real problem a real problem. That's because we have a lot of light and a lot of dark in the same image when we're talking about dawn and on sunset. And so that our most of our problems will be mainly with sunset or when it's dawn.
Yeah.
Because we have a lot of light in the sensor and a lot of dark areas. If we increase the gain a lot to get things from the dark areas, then we reduce the dynamic range, and so we get nothing from the bright areas.
Yeah.
So it's tricky, but it's doable, of course.
Okay. And I assume, David and you are testing this with the camera. You can even test it outside in dark and daylight on the live view.
Yeah, David was playing with it, and he showed. I just saw some videos. It was great.
Yeah.
But it was just playing with the exposure. And I think he was just playing with it inside his house. I don't know. Is David still around?
Yeah, still here. So.
Yeah, perfect. So, but anyway, we just have to figure out that. But but that's okay. We are already on a very nice path. So I'm happy.
Cool.
I would demo it, but it's on the Pi, and I'm just on my computer at the moment. I can this week. I'll integrate something with the gain. Fabio, like I say, I was just working with exposure, but I can start to see if I can do something with gain as well.
Yeah, we just have to figure out the best parameters, and so. And my point is that we just have to think about the amount of frames per second that we want, and then we limit the amount of exposure that we can like we have to we always have to go with the minimal gain, okay? But we have a limit on the exposure that we can put. So if we up to 50 milliseconds, then we just play with the exposure. If it's above 50 milliseconds, then you have to start playing with the gain to achieve something.
Okay. I was going to ask a question. I don't know whether this will be any use, but on the security cameras, like the dark security camera, it has like a day profile and a night profile, and you can save those profiles. I wonder whether you could offer the user that option. Where you have some bounds for exposure where they can't go beyond.
Yeah, I can remember. There's a menu. You can only set a certain point in time where you switch from day to night, for example, and back from night to day. And then you can set some exposure values, and I think I set all for automatic. So the software does it somehow. The driver, the firmware on the camera does it.
Right.
But I can't tell you any parameters what the driver is doing in this particular zone or time, day or night. I have no idea. It's just you can take automatic, and then when you switch from automatic to custom, you set gain, yes, and something else, but it's not exposure, because exposure is a topic by itself. Oh, sorry. But I think it's not that important actually, because if you set the exposure, you're not working from the video files, the existing training material, but from the live view from the camera. No?
Yeah, we just take the brightness of the frame and then it adjusts the exposure automatically based on that over time. I was thinking about the security cam, just to try and see if there's any ideas I could get from that. If you have like a day profile where there's a certain set of parameters you recall when it's daytime, and then a night profile.
When it switches,
Yeah, it switches automatically between the two, and maybe there's some auto tuning going on between. Within those profiles, slight changes to adapt to local conditions.
Okay. I will check the menu, what's stored in it, and I will give you the figures of day and night and what the difference is. if that helps.
Yeah, I've got one here actually, Richard. I can have a look. I've got I've not plugged it in for a long time, but I'll have a look as well. Yeah.
From your Tahua camera.
Yeah, I've still got it in the cupboard somewhere.
Okay. Now I thought because of the trainings material it was created with my Tahua camera. So I thought you want to see what the parameters were, where this material is based upon.
No, I was more interested in the operation of the security cameras, and when you're switching the camera on, you've got the option of having like 2 different profiles, one for day, one for night, and then I'm guessing with Sky 360 we'd like to have something similar. We have allow the user to set a day and a night profile, or do we just set it automatically in the software? Do we let the end user have any control over the parameters at all?
So I think basically the user should not have any control over that. The user, the stationer, has access to the server, or who built the server, because if he or she does wrong, the outcome will not produce good material for analysis. So I think we shall encapsulate this, and yes, as we did on creating these images, it is already encapsulated. So I think it's not of a question that the end user is doing anything, setting anything up. We have to do it all automatic.
Okay.
Because otherwise we couldn't control it.
Yeah.
And
So I wonder if you could,
yeah,
you could have one set of parameters for day, one set of parameters for night that would be universal and applied to everybody's station, and then some sort of local tuning that occurs, like auto exposure and with gain thrown in there as well. Yeah, I'll play around with it this week and see if I can.
I mean, you got the sun rise and what's the opposite of sunrise? Sundown. Okay. And you also have the idea of full moon, something like this. I think we can create several situations, especially when you. No, actually, it's not a good idea. If I think about it.
And the thing, David, is that the gain and the exposure and things like this change. It varies a lot with different sensors.
Yeah.
When you are talking about a sensor for a security camera, and the gain and exposure settings will be totally different from the sensor that we are using on the QHY 1 and 3. So it's they are completely different. We can see what they use just for reference, but it will be completely different on value wise, talking about different sensors.
Yeah, I agree. I think it was more about having the kind of process of switching between a day and a night profile.
Yeah, I got it.
The general idea for doing that. So I thought in that QHY app that you have, Fabio, whether you could have like a drop down box where you could choose day profile, and then it would switch the parameters to day profile, and then within that day profile it would tweak them slightly and tune them slightly to the conditions. If it's overcast in the day, it's going to be different to a full blue sky conditions.
Yeah, totally different than the night parameter. Night parameter will be mostly fixed because the amount of light in the camera will be just too dim, just stars and.
Yeah. And then just having if we have it within the app where you could switch it to a night profile, you could test the night profile then and see how the camera's operating at night, how it's working at night. But I guess there's so many different things that play into it, isn't there, with light pollution and whether it's a full moon.
Yeah. If I might make a remark, It does seem to me that it would be worthwhile to incorporate some sort of ambient light sensor, okay, into the design. Not necessarily on the Aloha version, but as a Gen 2, Gen 3 kind of thing. And the logic there is simply that by getting a direct measurement, be it either like watts per square meter from a metal plate in a thermocouple, or something simple like a photocell, something like that, I think it'd be a good thing to incorporate. And worst case, okay, you find out it's just not that useful. But for example, I happen to know down around like the San Francisco Bay Area, you get over the first range of hills from there, even in the middle of the night, because of all the backscatter light from all the city lights on the other side of the hill, it might as well be daylight out. Just very minimal eye adjustment, and you see just fine. And I'm sure other cities are, and significant urban areas have that characteristic. And so to have some kind of simple thing sitting there that we can say, okay, this is what background light is looking like. If there's an adjustment we can make to compensate for that, fantastic. If there isn't, okay. But I do think it's worth looking into and building a sensor or two for it. So just my humble opinion.
Whoa, Fabio!
Oh,
Hey, Mazel tov! Is it a she or he?
He,
A he?
Julia, Julia, she.
A she, a
She.
Julia.
yeah.
Great. How many days now?
1 month yesterday.
Oh,
30 days already. Wow.
30 days,
Yeah.
yes.
Wow. And the cat is curious what's going on.
Yeah,
Is she jealous?
yeah, the cat is yours.
Jealous? Oh, poor cat. Now you're second in place.
sorry.
Yeah, so I say for this whole topic of exposure, I think we should sit together with people like Christian, astronomers who have a deep insight into this, and you, Fabio, and David, and hack that out and really make a special meeting just for this topic. I think it's important that we do that, to have the
Yeah,
discussion.
true. I totally agree.
Yeah.
Yeah.
Okay, let's make this a special topic next time. I'm talking with Christian that make sure that he's there. Okay. All right. Yo, guys. Anything left for today? Anyone from you want to contribute anything at the moment? If not, I'd say we close this developer meeting and I stop recording.